have pushed the YouTube stream live. Welcome again, everyone. We have Denny, Burak, and TD here to talk about Delta Lake 0.7 and Spark 3.0. If you haven't subscribed to the meetup, if you just found this link from one of your friends or colleagues, please do subscribe to the meetup to hear more about our upcoming sessions. Denny has been organizing, I think, 2 a week here. So lots of great content, including one, I think, on Thursday, right, Denny? Is that? You have one on Thursday coming up about Glow.
That's right. Yes. Glow. In fact, I'll take care of that, so no worries. But yes, there's a one on Glow this Thursday, and we also have 2 Delta Lake sessions next week as well.
All right, great. Well, let's get started here, Denny.
Perfect. Well, thanks very much, everybody. Thanks, Ryan, for introducing everybody who's on Zoom webinar or YouTube Live. Glad to have you. This is, just in case you're wondering what you stumbled in on, this is the Delta Lake 0.7.0 plus Spark 3.AMA with Burak, TD, and myself. All right, just as Ryan had called out, if you love this type of material, please log into our Databricks YouTube channel to sign up. And as we noted, the recordings and the slides are going to be available after this tech talk or webinar. Note that it's on YouTube Live anyway, so basically it'll just be there. Everyone is muted, so please put your questions in the Q&A panel, okay? And then that way we know what questions you're going to be asking. One of the things we'll note is that we're actually going to present some slides to encourage folks to basically ask some questions. Okay, so right now we're going to start off explaining some of the features that are available in Delta Lake 0.7.0. All right, so the quick call out here is that Delta Lake 0.7.0 is the first release on Apache Spark 3.0 and adds support for Metastore defined tables and SQL DDLs. So pretty cool. Now that we're on Spark 3.0, woohoo, yes. All right, so now, what do we mean by this support? Okay, so some examples. Okay, and this is the part where we're going to say, hey, if you've got questions, please prop them in the Q&A panel because we'd love to actually hear them. Okay, for TD and Burak, they're probably going to be doing most of the answers. So Burak, TD, since right now I'm presenting, I actually can't see the Q&A panel because of the way Zoom works. So if you see any cool questions or you want to add in some color commentary as we go through these slides, by all means, let's go do that here. Okay. All right, so let's start off with the context here. Support for defined tables in the Hive Metastore, right? So now what you can do as part of Delta Lake 0.7 is define tables in the Hive Metastore and use, excuse me, sorry about that. There we go. And use the table name in all SQL operations. And so what do we mean by that? There are things like we can create the table. For example, your standard create table, like events, you have your schema, you specify using Delta. So in other words, you can write this as SQL operations, okay? As opposed to necessarily just using the Scala or the Python API. But just as important, all right, you can also use the alter table statements. So you can actually add your columns as well. So making changes to the table and or the schema in the process. So it's pretty cool that you have the capability of doing that now. Cool. TD, Burak, any color commentary or questions that you can probably answer right now?
The one comment that I want to add is like these commands looked like they were working in previous releases of Delta Lake and Spark. But the thing was, all of this information was actually stored in the Metastore. They weren't actually delegated to Delta in the correct way that it should have been. Therefore, now what we mean by, there is support for things in the Hive Metastore is that whenever you actually access a table by a name, it actually can delegate the operations to Delta and its transaction log properly through Spark.
Cool. So friendly reminder, if you have questions, please put them in the Q&A panel as opposed to the chat panel. But actually, there's a great question in the chat panel, so I figured I'll ask either TD or Burak to answer this question right from the get-go, is can you help us understand more about the Metastore?
Yeah, sure. I mean, so what is the Metastore? The Metastore is, let's say, a construct that, currently is backed by Hive, which we call the Hive Metastore. And what it does is that it stores all the metadata about all your tables. in it. So what does it do? It can store like the schema of your tables. It can store where the table is saved on some object store or some JDBC URI, or whether it can even be Kafka, for example. It can save like a Kafka URI and whatnot. So what it does is that like it's basically a database that stores all this information. It can store like partitioning information for like tables which are backed by Parquet, for example. And whenever you query your tables, what Spark does is that this identifier, for example, in this case events, we will go to the Metastore to figure out, does this table really exist? What's its schema? Where is it located? Which format do I have to use to read this table and query this table? And all that information is gathered through the Metastore, typically. With Delta tables, what happens is there's just a table name, the fact that it's stored as Delta in the Metastore, and the location of where it's stored at. So it's kind of like a layer of indirection for you not having to remember long paths about oh, is this stored on HDFS? Is this stored on like some object store or whatever? You just remember the name of the table, and the rest is just handled underneath the hood.
Perfect. Thanks very much.
So,
okay. Oh, sir, go ahead,
Let me
please.
add a bit more color. I think, well, first of all, Burak is, I think, selling himself short. He's not saying the fact that he has spent last 2 years working with the Apache Spark community to add this support. So basically, before Spark 3.0, Spark did not expose the right set of APIs to customize this Spark to Metastore interaction. So Spark used to always read the schema and other associated metadata from the Metastore given a table name. That was not customizable. In Delta, we wanted exactly that. We wanted it to customize it so that instead of reading it from the Metastore, it reads it from the transaction log. And Burak did all the effort, almost all the effort, in all the changes in the Apache Spark to build the right APIs, etc., to customize that up. Customize that interaction. And that's why Spark 3.0 is such a major jump in functionality compared to Spark 2.x, because we could customize the interaction in Delta and give Delta a first-class support of tables.
Yep. This data source V2 effort was like a multi-year effort, with people being supported from all over the world. So it was like a huge, like community get together to like help such data formats such as Delta to work with Spark in the right way, basically. So it's like a humongous effort from like people from the community. So that was like very impressive.
Perfect. Thanks very much. So we've got some other questions that have popped in the Q&A panel. So Burak, TD, why don't you take a look at them? I'm going to take a couple right from the get-go. For the first one, which has absolutely nothing to do with with Delta Lake, how's the coffee brewing? I'm currently brewing espresso vivace coffee, and it is awesome. So I believe I've now answered that question. Burak, TD, do you guys have your own version of this? Fair enough. Burak is the healthiest one with water. All right, fair enough. All right, so next question here that we can answer, and I can take it, or TD or Burak, you can take it. Can Delta tables be created using the Glue catalog? Okay, and then, go for it, Burak.
So can Delta tables be created on the Glue catalog? TD, you have a little more context here potentially, I would say, but the idea here is that, Spark can be backed up by the Glue catalog as well. And, Delta can work in such a way that you can use the Glue catalog to store the information. But the caveat here is that, the information that Delta stores in the catalog or the Metastore is very minimal. It just stores, like I said, the table name, where it's located, and the fact that it is a Delta table. So through the Glue catalog, you might not see information about what the schema is directly from Glue. which is kind of like what people typically care about. So the difference there is like, can Spark use it with Glue? And, if you query your Delta tables all the time from, Spark using this Glue Metastore, yeah, sure. But do you get like the full experience of, like all the information is within Glue and you can take, like a look at it from some UI? In that case, no.
Yeah, so let me add to that. I think basically theoretically it should absolutely be possible for Delta plus Spark to use Glue. Actually, on the managed Delta Lake on the side of Databricks, we have actually made that work. But I think that required some additional work to make Spark behave well with the glue-backed Metastore. I think that is some amount of work that probably the open source community has to develop before it can actually start working properly. But we have it working on the Databricks side of Delta Lake.
Perfect. And then I think a natural progression, which you sort of already covered, but basically is, can we query the metadata to find the details from Databricks? And so I think there's that context that we're saying some of this is available within Glue itself, but some of it's available directly within the transaction log. So perhaps TD or Burak, you'd like to elucidate a little bit on that.
Yeah, I mean, since like the whole idea is getting all that information from the transaction log, yes, within Databricks, you can like query through JDBC or, your access, method of source to get all that metadata information through Databricks as well. Within open source, once everything is hooked up in the correct way and you access through Spark, that should also be possible. Excellent.
And then I think in Variable, we have another question, which is great. We have questions pouring in. So is the metadata of the Delta table actually cached, and how often is it refreshed?
Great question. So since Delta has to, like compute its state, and the state computation could be arbitrarily expensive, as the Delta table gets updated and the state is computed, that state is cached on whichever Spark cluster that you're running it on. But anytime you access that Delta table, it's refreshed. And this refresh mechanism can be done synchronously or asynchronously. It's totally up to you. But what we do is we just check the transaction log to see if there are new files there. And if there aren't, then we can just go ahead with the cached state. If not, we have to compute the cached state.
Perfect, perfect. Okay, let's continue on. We actually have some other questions here, but I figured let's go ahead and at least talk about some other stuff, and then we'll go back to some of the other questions that are there, okay? All right, so that was actually just the first slide about defining tables that have Metastore. All right. Oh, right. And the second slide, which was to follow up on that, was basically here's how you would define it. You can define it using the data frame right, save as table name. Save as table, excuse me, the data frame right to, or Delta table for name, API instances. Okay, so we basically made it easier for you to do those definitions. Okay, so just as a quick call out, slides will be available. We're actually referencing the document, and on me is the follow-up blog to provide details on this stuff as well. So we're gonna make sure we write that blog and get that out as well. And that's TD looking or Brock looking at me going, you're only 2 months late. So yes, my bad. All right, so a cool thing, absolutely, and I'd love to see some questions based off of delete, update, and merge. So the idea is now that you can, instead of just using the PySpark Python APIs or the Scala APIs, you can actually use the SQL DDLs. Okay, so you can run delete events, you can run updates, you can run merge into. If you've already been using Delta Lake on Databricks, you probably are already, hey, that's there. it is because we've been able to beta test it this entire time, and we gave you early previews. But now it's available for the full open source. And exactly to what TD called out, a lot of it actually had to do with some of the work for the multi-month, multi-year work that Burak and the Spark community did in order to get data source v2 in, the catalog IPs, and all these other things. So that way we can provide things like these DDLs. Merge into is definitely one of our favorite ones because it allows you to do upserts, i.e. insert and updates, which is sweet. So, we've got a lot of cool
deletes.
Oh, thank you. Sorry, my bad. My apologies.
Yes.
My fault. I apologize. I was about to say also deduplication too. So
Yes. So to add color, basically the merge SQL syntax we support in Delta via Spark data source v2 now is one of the most advanced merge syntax out there in the community. It's even more advanced than the Hive support of merge. There is, it is because you have support for both update, delete, and insert clauses, which is beyond the standard syntax, but Hive supports that. But beyond what Hive can support is this additional syntax where you can just essentially update. You can just say update star or insert star, where all the columns would be updated at the same time, which makes it much simpler to do upserts when you have 100 columns and you don't have to write out the entire merge query with 100 columns. You can just say update star and the target table columns will be updated with the values of the corresponding name columns in the source. It's a much better shorthand, one of the most heavily used extended syntax that we have seen. So all this comes with Spark and Delta only, and I don't think any other open source project has these additional syntax that makes it the life of a data engineer working with these or data analysis much easier.
Cool. So let's toss in some questions. We actually have a bunch of glue questions. So I'm going to go ahead and wait till a little bit later because I think there's some additional information here that might be helpful. Let's see. Oh, okay. Let's see. Here's an interesting one. Can we ignore the auto refresh and use only the cached ones in case of daily ETL jobs where we don't care about the very latest updates? So I'm guessing for the person who asked the question, we might need some additional details, but it seems to me that what you want to do is you want to be able to just use the cache data that's stored in memory as opposed to actually going ahead and looking at, like, for example, new streams or new batches of data. I think that's the context. Yeah, Burak, TD, what do you think? I mean, like,
yeah. Even in the case where, like, if the data is cached in memory or, like the state of the table is cached, we do have a staleness limit configuration where you can define your Delta table to be as stale as you want. But the idea there is, like, hey, you can set, for example, for a daily, ETL job, you can say like, oh, my staleness, I care about, like 24-hour staleness. What that does is that, like if you have queries coming in, they will use the in-memory cache state directly. But in the case, it will still trigger an update, underneath the hood. And hopefully if your, like update of the Delta state happens within those 24 hours, you will still continue to use the latest state of the table. If you would like to just like fix your state and, use that moving on, what you can do is you can define a view and leverage, basically time travel, saying that I want, to select this table timestamp as of this date. And that way you can actually just like fix yourself to a specific snapshot of the table during that day. And you can use things like current date to make sure that you always get like today's data or something.
Perfect, perfect. Okay, let's continue on. Just so that way we at least talk about some of the other cool concepts, and then we'll go back to some of these questions. Okay, because so many are coming through. So, TD, Burak, as we continue on, if you could take a look at some of the questions that you would like to go ahead and answer, ones that you don't want to or are not appropriate, obviously dismiss. But most of them are pretty cool. So obviously, let's just try to organize them and answer appropriately. Okay. All right. So actually, there is a question here specifically about, was it? Sorry, I'm trying to find it, about Presto and Athena. There you go. So the question, which is actually a good timing here. So do we still need to define tables in Athena, Presto using symlinks, or can we use the new SQL method of defining delta tables via the glue catalog? Okay, so we're not going to talk about the glue catalog just yet, okay, because I think, but I did want to go ahead and call it specifically this context: automatic and incremental Presto and Athena manifest generation. So prior to Delta Lake 0.7.0, right, in order for you to connect your Presto or Athena to Delta Lake, you would generate the manifests of a Delta table using Apache Spark. And so the manifest basically, if you look at some of our previous Tech Talks, what we did is we explained the concept of how there's a transaction log. The transaction log basically tells you what's the latest Parquet files that you're supposed to be reading. Okay, so this also allows us to do time travel, basically data versioning, things of these cool things. Well, what is the manifest? The manifest basically is a file that's generated that tells you what are the latest files for you to work with. So that way, when Presto and Athena are saying, "Hey, give me the latest Delta Lake information," we've generated a manifest that says, "Here are the files that Presto or Athena are supposed to read." So number one is to generate those, and then number two is to configure Presto or Athena to read those generated manifests. So in other words, basically read a list of files that says, here's the Parquet files you're supposed to read. This contains the latest information. Woohoo. All right. Straightforward, except for the third point, which is, how about if you're continually updating it, right? Well, prior to this, you had to manually update this information, right? So in other words, you had to go back and say, okay, now I'm about to have Presto query the stuff, query my Delta Lake table. I need to manually update that. Yay. Except no, not yay. So some great work from the team, which is to basically, as part of 0.7, is to do that automatically. And so you'll notice basically the SQL syntax: alter table, set table properties, and then if you set this table properties to the symlink format manifest is enabled to true, then it'll automatically update the manifest once you've generated. So that way, your Presto and Athena instances be able to go ahead and query it to your heart's content. Okay, so pretty cool feature that was definitely asked for by the community. So pretty happy about that. All right, so let's see.
So the question,
yeah, please.
I think we should answer the question specifically. Do we still need to define tables in Athena Presto using symlinks, or can we use a new SQL method of defining delta table via glue catalog? I think it's a good question, but it's a complex question. I think we should address that. So let's separate out, let's understand what is going on underneath and separate out the problems. So there is, with 0.7.0, we have made the ability to define and put the minimal metadata needed to associate table names to the table location and put that in the Metastore. But ultimately, whether you can use that metadata to query the delta table through the delta table's transaction log or not, that is something that needs to be explicitly built in. And that is there in the delta, so in the delta implementation inside Spark, but that is not there in Presto Athena yet. So while Presto Athena will be able to see the table definition in the Metastore, where if you connect the Presto Athena to the same Metastore as you are using on the Spark side, so it will be able to see the table definition, but it wouldn't know what to do with it it wouldn't know how to use that metadata to read the transaction log, because Presto does not yet understand the concept of transaction log. So yes, while it is visible, you cannot yet use the table directly in Athena Presto. So you still have to continue generating that manifest, because that's what Athena Presto understands. Hopefully that clarified the question.
Cool. I mean, I think so, but so any other context or concepts before we continue on with the slides? All right, perfect. All right, we looks like we have we have continued questions. So I'm going to just go ahead and finish off the slides. We only have a few more anyway, so let's go ahead and do those, and then we'll go ahead and go right back to the questions we have here. Okay. So we're going to go ahead and now with these particular callouts, we can also control your table history retention, right? So basically the log retention duration controls how long the history for a table's kept. Don't forget, with Delta Lake, with the time travel capability, right, you are able to keep the history of your table, but sometimes you want to be able to control how long the logs are kept, i.e. the transaction log, and how long the actual files need to be kept, the actual Parquet files, right? So the log retention duration controls how long the history for that table is kept, i.e. the logs. And then the delete file retention duration controls how long ago a file must have been deleted before being a candidate for vacuum. Because don't forget, when we delete, we're not really deleting per se. It's more of a tombstone. What's happening is that we've told it to be delete. We know the information is like now there's a new version, right? Well, when we run the vacuum, that goes ahead and clears out older versions. So now you're saying, now I want to specify exactly what that history retention is going to be. So we just want to give you that control. And so we're given the API calls right here for you to do that. TD, Brock, anything else we should add?
Yeah, one common like misconception I want to add here specifically is that, when you use vacuum only deletes data files that are not tracked anymore, that don't have tombstones anymore. The log files themselves, so people typically look at the log directory and then see that, oh, here are files that are older than 7 days. Why are these still here? They ask these questions. The log files are deleted separately as part of the checkpointing process, which Delta does right now at every 10 commits. It kind of like aggregates the entire state of the table, dumps it into a Parquet file so that, we don't have to read thousands of JSON files to, calculate the state of the table. Once this checkpointing is complete, then files before these checkpoints are safe to delete. So therefore, log files are deleted using this log retention duration setting after checkpointing completes, not as part of vacuum.
Cool. All right, let's go ahead. We only have a couple. Oh, sorry, go ahead.
Denny, hold on. So there is one question that is probably related to this is there a possibility that log compaction into a Parquet file lose time travel information?
Right.
Burak, do you want to chat about that? Because it's very related to this.
Yeah, fantastic question. So when we're doing time travel, we don't leverage the snapshots. Time travel is achieved through the JSON files, the individual commit information. Therefore, in order to be able to do time travel, you need a compacted Parquet file and all the JSON files after it. So this is all governed by this like log retention duration setting. As long as your log retention duration setting is like 10 days, for example, there will be a snapshot that's at least 10 days old. And then you can go and compute something that's like 7 days ago, for example. That's a great question.
Actually, and related to that, what's the maximum log retention duration supported?
Also a great question. It really depends on you, I would say, how much you want to pay for costs. Typically, there shouldn't be any like upper bound. But if you're having updates to your table every minute, then it doesn't really, it's not a cost-effective option to store years worth of logs. The idea there is if you want to do time travel over years base of data, then you should probably have, but your data is being updated every minute, for example, but you need years worth of time travel. You can either have an archive table, a separate table where you archive the data once a day, for example. And then if you have 10 years worth of data, 3,650 logs, that shouldn't be too hard to manage. But if you're having like updates every minute, then you might want to store data as like SCD type 2, for example, data, and query based on filters instead of trying to do time travel to figure out what the state of something was at a given time.
It would help if I unmuted myself. Cool. Thank you very much. All right, let's. We only have 2 more slides to dive into it, and then we'll go back to the questions. So we actually have lots of other good goodies as part of Delta Lake 0.7. There's support for adding user-defined metadata, and when you're running your Delta table commits, support for ADLS Gen 2. Because Spark 3 has support for Hadoop 3.2 libraries, this actually enables basically for Delta Lake to have support for working with ADLS Gen 2 now. Okay, so for all of our Azure Databricks fans, or for that matter, Azure fans, then yes, woohoo! Now we're working on ADLS Gen 2. Also improves support for streaming one-time triggers. With Spark 3.0, we ensure that the one-time triggers, i.e. trigger.once, which we often use in examples when we're talking about like how you can take streaming to work with even what is traditionally seen as batch-based processes, right? But it works really well. So the idea is to take the trigger.once processes on all outstanding data in your Delta table into a single microbatch, even if the rate limits are set with data stream reader option, max files per trigger. So this basically allows a much smoother run for when you're using trigger once. TD, like to add anything on that, just in case I mangled it?
No. You actually said it correctly. Just, I think, let me add a bit more context on people who may not be familiar with trigger once. Basically, what the trigger once mode is that you write a streaming query using Spark structure streaming, but you can, instead of running that streaming query continuously 24/7, you can run it like a periodic batch job where you say that start this streaming query in trigger once mode, which will essentially do only one trigger to process all the available data and then shut itself down. So that basically, instead of, if you do not have very tight latency requirements, you're okay with few hours of latency or 1 day of latency, you can run the same streaming query. Instead of continuously, you can run it like using Airflow or something triggered, externally triggered, one-time batch job to process all the new data available and then shut down. And then maybe 6 hours later, 12 hours later, or 24 hours later, run it once again. The good thing of running it in this model is that you are leveraging all the internal advantages of structure streaming in terms of maintaining metadata, figuring out what has been processed, what is yet to be processed, ensuring end-to-end exactly one's guarantees, etc. You get all the goodies that comes with structure streaming, but you are essentially a lot more flexible in your resource cost versus latency trade-offs that you can do. So there, the semantics that usually is desired is that when you do run this trigger, this one-time trigger, you want to process all the outstanding data. So earlier there was a kink where if you, in the Delta data source, you can define limits that in each trigger or in each micro batch, how many files to process. If that is useful for 24/7 operation, you don't want that to be considered when you want to do trigger once operation, because you want to process all the outstanding data. So that kink has been fixed as part of this Delta 0.7.0, making it much smoother to use it with structure streaming in this trigger once.
Cool, rock on. All right, well, how do you enable all this? So we've talked about all this cool stuff, but the one thing that we want to make sure we've called out is that you actually need to enable data source v2 and catalog API integration to run the aforementioned features. So to do that, basically, we just called out exactly the Spark session config modifications that you have to do. So just make sure you do that. When you create your new Spark session, you've called out the fact that you are enabling the SQL extension, the Delta Spark SQL session extension, and the catalog, right? And then once you do that, then all these features that you see here in the previous slides, boom, now you're actually able to go use them. So pretty cool. I don't think there's anything else to add here, but that's about it for this one, right? TD and Burak.
Yep.
Sweet. All right. Well, then let's dive into questions. We still have plenty of questions here. We're probably about 10 minutes worth of left. I'm going to start with the first one, but then if you guys see questions that you like to answer, by all means, let's go do that. So the first thing I'm going to call out is like, what's the performance impact on live queries when a vacuum is in progress? Okay. So as a quick call out, I want to provide context for anybody that's, relatively new to the context of what this is. Vacuum is basically deleting the older files, right? Just as per that log retention, duration, excuse me. The context is that we're going to delete, when you run vacuum, we're going to delete all the files that you're saying it's older than 7 days or older than whatever days, and we're going to remove them, okay? The question then in hand is that, will that actually have an impact when I'm trying to query data at the exact same time? Okay, so I'm trying to run a process that's deleting data at the same time as I'm trying to run a process that's actually querying the data. So Burak, TD, I'm sure you have plenty to add in, and for that matter, so do I, but I want to let you guys start first.
Yeah.
Burak, go for it.
Yeah, I would say like the cool thing here is multi-version concurrency control. That just says that, like with multi-version concurrency control, which files you actually have to query, which files you don't have to care about. And with this separation, like vacuum is entirely its separate thing. And it's touching separate files than the files that you're querying, even if they are like, could be in the same directories. Like neither the object store nor Delta really cares. So, like you shouldn't observe any performance implications here. And like one of the reasons that you don't observe any performance implications is because Delta doesn't need to list directories or list files to figure out which files it has to actually read. Vacuum is a very, object store heavy operation. Both the entire listing and the deletion operations are pretty heavy operations on the object store, but these don't affect the, get performance, for example, of these files specifically.
Okay, one assumption though, and this is a semantic assumption, that you are not vacuuming the versions that you're querying, maybe using time travel. So say you want to vacuum every version that is more than 1 hour old than the current version, then you probably should not be querying using time travel any version older than 1 hour. So as long that semantic guarantee is ensured at the application level or at the user level, they will not interact with each other.
Yeah,
right. And actually, exactly to your point, so this is something we're guilty of, and so that's actually what I want to call out, which is the fact that we actually have a lot of demos where we actually tell you vacuum zero. Now, in those demos, when we're running vacuum zero, we do actually make sure to actually put comments, don't ever run this in production, okay? And the reason we're saying is basically, is because the reason we're doing it in a demo is just to let you know, okay, now you've deleted the files that were older than what's right now. So let's say you have 10 versions or 10 data versions, and basically every single version has been deleted except for the 10th version. That's great. And then when you run a query to look for the previous version, it'll error out as appropriate because the data is no longer there, right? So that's all good and fun. But that's the reason why we tell you, yeah, like exactly to TD's point, like, yeah, if you want to be careful when you run, how long ago, the history that you're running your vacuum, because if you do, yes, invariably, you're going to run a time travel query at the same time as you're deleting it. But again, that's not that common. And the most common played out is exactly the way we described it, which is, the data is 7 days old. Okay, yeah, we're not time traveling 7 days, anything older than 7 days, then we're perfectly cool. But just want to call that out, okay? All right, there's actually a couple questions that I think TD you would love to go dive into, so I'm going to call you out right from the get-go. Is basically first, it's actually related to structured streaming and then a scenario related to structured streaming. Okay, so the first question about specific structured streaming is, in structured streaming, is there support for all output modes for Delta Lake, since files themselves have only append-only modes, and so, or excuse me, append modes, right? So why don't we start with that, and then we'll toss into the scenario right after that.
Yeah. So as of now, Delta supports only append and complete modes similar to files.
Right.
That said, if you want to upsert something into a Delta table by using update mode like thing, what you can do instead, while it's not a first class support, you can't just simply say format Delta dot output mode update, not yet. But what you can do instead is you can use this other operation called for each batch,
Right.
where, for those who are not familiar with structured streaming, what for each batch allows you to do is specify an arbitrary function to do whatever you want with the output of one microbatch, of each microbatch of a streaming query. So let's say you have a streaming query that is computing aggregates, which is going to inevitably generate key value pairs, key and aggregate pairs, and the aggregate will keep updating. If you want to write or essentially upsert those aggregates into a Delta table, instead of update mode directly, you can do update mode for each batch, and the output of each batch will contain the updated aggregates that was updated in that micro batch. You can call merge on top of that, on that batch output data frame. And so it'll be for each batch, for each of the batch data frame, Delta table dot merge into the target table using this batch output data frame as the source. And there are examples on the Delta Lake docs for that. So you should be able to very easily copy paste that and start building on top of that. So you can do, even though that is not yet a first class support of update mode, that is something we'll be working towards in the long run, but you're not blocked by that. You can totally build update mode yourself by writing the for each batch and merge.
Perfect. So then related to exactly that, TD, so can we use Delta Lake in scenarios where the tables are updated frequently, say every 5 minutes? Basically, we have tables stored in an online system, and we want to create an offline system using Delta Lake and update the Delta tables every 5 minutes. What's the perf and cost implications? Perf and cost implications for doing something like this?
Okay, so yes, absolutely, you can do that. I think the ambiguous part in that question, which I don't get, is what does online system mean? So if you are talking about maintaining an online system like a database, so a common pattern, for example, let me use a pattern to common usage pattern is there is TP-CDS style online, there is a OLTP style online databases that are used for online transactions for fast lookups, point lookups, etc. And often people do is that in order to do larger data analysis on the OLTP data without actually affecting the OLTP database, people take change data from the OLTP data, take the change log, stream it, and using merge, upsert it into a Delta table corresponding to that OLTP table, and therefore build an OLAP kind of data warehouse in the Delta table format. That's a very common pattern we have seen our customers as well people in the open source community do. And so basically you have essentially the same data that is sitting in OLTP database for your online transactions, as well as it is continuously synced with low latency, like potentially 5 minutes, absolutely, into a OLAP style data warehouse for more heavy duty aggregation, that kind of queries. So that is absolutely possible and is a pretty common pattern.
Perfect. Okay, we probably on time for a couple more questions. So for anybody that we're not answering questions, we apologize in advance. What we're gonna do is because I owe everybody a blog on Delta Lake 0.70. What we'll do is in addition to writing that blog, we'll make sure to actually answer as many questions that we didn't get the chance to answer and prop that into the FAQ for this as well. Okay. But a fun question, just because I also do the same thing on a regular basis, even though it's completely unsupported because Brock will just hit me for doing it. Can we undo a specific or last operation in a Delta table? Like as in, okay, and manually deleting the JSON for the _delta_log, right? But this is probably not supported and probably will leave your transaction log in an inconsistent state. So, Burak, by all means, why don't you tackle this one? And I'll add my color commentary too.
Yeah, had a garbage truck passing by, so I wanted to mute
Actually, so did I.
Yeah. Yeah, great question. We do not recommend you tamper with the Delta logs, especially do not ever delete anything, like don't delete an intermediate version or something. It's against Delta's protocol to overwrite Delta logs. It's against Delta's protocol to manually delete those Delta logs. In open source, the easiest way to, like undo your operation, it won't unfortunately be a metadata only operation, is to just replace your table by using, with actually Spark 3.0, we do have a replace table syntax right now. And you can use time travel and that replace table syntax to overwrite the data in your table. However, we do hope to add support for rollbacks, but which we're planning to call like restore in the near future as well. But it's unclear on when that can be easily pushed out to open source.
Cool. And then relate.
So hold on.
Oh, sure.
On that note, when Burak says replace the data in the table, you can do it at a partition level granularity, where if you know that some operation that affected part is a partition of the entire table because it got corrupted or incorrect operation, you can do it at the partition level granularity. So that is, you don't have to replace the entire table on this.
Yeah. So related to the transaction log, just because a lot of people like playing with it, but it's a good question, by the way. If the Parquet metadata file is created after 10 commits. Now, remember, this is the call out that after 10 commits in your transaction log, and basically the 10th one is a Parquet file as opposed to JSON. Okay. Does this mean I can only go 10 commits back, or time travel queries just ignore the Parquet metadata files? And so I'll quickly answer a little bit, but Burak is the lead on this stuff, so I want definitely him to take on most of it. But no, you can certainly go farther back than 10 commits. So let's just start with that. Okay, so there's no problem with this. The creation of the Parquet checkpoint files is about performance. And so Burak, why don't you take the rest of it and provide the context here?
Yeah, exactly. So the Parquet files are written after the JSON files are also written. So the Delta files must be written first, and then the Parquet files are just an optimization, as Denny mentioned, to speed up, the state computation. So you can definitely go behind more than 10 commits. It's basically the log retention duration defines that, okay, like there will be these JSON files and at least, like a checkpoint file before I start deleting these things. And what we can do is, for example, go back 30 days, keep a checkpoint file and keep all Delta files after it. That way we can always, like compute any state in the transaction log.
Perfect. Okay, so actually, we're gonna wrap it up with one more question, and then we're gonna wrap it up. Again, apologize for folks that we're not able to go ahead and answer your questions, but like I said, for those, we're gonna go and write an FAQ, and so that and get that out for everybody. So we'll have the blog and FAQ that covers a lot of cool stuff. All right. So the question is, what can we not do in 0.7.0 that we can do in Databricks Delta? And so I'm going to actually give you a slightly different answer than you're probably expecting, which is, what's the premise of what we have in the Delta Lake in Databricks versus the Delta Lake that's open source? So the context from where we're coming from is that we're working very hard to get Delta Lake so every single API that you see in Databricks is also available open source and the other way around, right? We want there to be complete and utter parity between the two, so that way anybody can use Delta Lake whether they're using Databricks or not, right? It's an open source project. It's part of the Linux Foundation, and so we're working rapidly to do that. Okay, and we're pretty close, but we still have some work to do. Let's be fair. That's why it's still 0.7, and we'll have an AMA in October for 0.8. So we're not finished yet, but we're getting pretty close, right? The goal. And I think if you ever listen to anything that Michael Armbrust would talk about in some of his previous videos, you'll hear him basically very clear. The APIs are open source. They're available. There will be absolute and utter parity. There will be some things like performance that will be specific to Databricks. That's true, okay? Because we're a managed service and we're going to make sure it runs really well on Databricks. But it doesn't mean you yourself cannot do the same thing when you're if you were to run the things yourself on your own Delta Lake. For people. There's actually a pretty cool question in terms of what's one of the cooler projects that here with Spark. Well, in fact, there's a pretty cool project with Spark and Delta Lake that's actually about astronomy data, to actually look at all the stars using those super powerful telescopes down in South America, in Chile, because they can actually go above the cloud base, so they can actually see everything and how they're processing all of that cool data. Well, guess what? They're running obviously on open source because they're a governmental agency, so that's what they're doing, right? But they're running also on Delta for precisely that reason. So we want to make sure that all the APIs are there for everybody to use. There will be some performance improvements within Databricks itself, but overall, what you see open source and what you see in Databricks will be the same from the standpoint of API usability and functionality. Burak, TD, anything else that I missed? Cool. All right. Well, then, ladies and gentlemen, I will go ahead and flip over here. I did want to remind everybody, for starters, I wanted to thank TD and Burak for this awesome session. And thank you for the audience here for you attending today's session. Again, apologize for not necessarily answering all your questions. We had a lot, so we did our best to go through them. We're going to go ahead and follow up with an FAQ. Meanwhile, we have some great data and AI online meetup sessions that'll be coming. This Thursday will be a GLOW WGR genomics panel with Regeneron and Databricks. It'll be talking about how we can do GWAS at an amazingly powerful scale, basically because of GLOW WGR. Okay, and then the following week, we'll actually have two fun Delta Lake sessions. The first one be with Douglas Moore and myself on generating surrogate keys for your data lake house with Spark SQL and Delta Lake. This is a follow-up to our SCD Type 2. We had a lot of questions about surrogate keys when we were doing our OLAP style SCD Type 2 dimensions and how you did that in Delta Lake. Well, this invariably led to surrogate keys. So there were enough questions that we just said, hey, let's go actually create a session specifically on that. Okay. And by the way, the same thing, as we hear more and more questions from you in these Q&A panels, even if we don't necessarily track all of them or answer all of them right away, we will make sessions based off of your feedback. So please keep on chiming in here. Okay. And for those of you who are still relatively new to Delta Lake, Louis is actually going to be doing a tutorial on how Delta Lake supercharges your data lakes on Thursday, the 27th. So that's it for at least for the next 10 days, okay, in terms of 3 different sessions in the next 10 days. So we hope to see you again on this. Again, thank you very much for attending this session. And I think that's about it. Guys, want to add in anything else? Cheers to coffee, you know?
Thank you all for attending.
Yeah.
Fun.
All right. Well,
Thank you
then
very
thanks.
much. Good questions.
Good questions. So thank you, Denny and Ryan.
Perfect. Well, thanks very much. All right. Take care, everybody.
Bye, everyone.